Once again, welcome back to the Math Revision Made Meticulous video series. Topic Vectors, Day 27, Scalar Product of Vectors. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per day from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Today we see the scalar product of vectors. If vector A and vector B are non-zero vectors inclined at an angle theta, then the scalar product of A and B is defined by A dot B is equal to magnitude of vector A into magnitude of vector B into cos theta. Sometimes we call it as dot product also, A dot B. Now let us see some properties of this scalar product. Vector A dot vector B is a scalar because on the right hand side you are having magnitude of A, magnitude of B and cos theta, all are real numbers. Therefore A dot B is a scalar. A dot B is same as B dot A. We will be using it while we are proving some results. And when you find A dot A, then the angle between them is 0, whereas cos 0 is 1. Therefore it is magnitude of A into magnitude of A into cos 0. Therefore magnitude of A square. We will use this result also to prove some important results. Then if theta is the angle between vector A and vector B, then by making use of the A dot B formula, we get cos theta is equal to A dot B by magnitude of A into magnitude of B. Already we have seen in the earlier video how to find magnitude of A and magnitude of B if they are expressed in terms of their components. Now suppose if they are expressed in terms of components, that is vector A is written as A1i plus B1j plus C1k and vector B as A2i plus B2j plus C2k, then A dot B is A1a2 plus B1b2 plus C1c2. It is just expanded. Then I dot I and I dot j, I dot k, all these values are put there. I dot I, j dot j and k dot k will become 1 and the remaining I dot j, j dot k, they will become 0. For you will get A1A2 plus B1B2 plus C1C2. This result you can take it for granted. Whenever you are having the components written there, then A dot B is the product of the components. A1 into A2 plus B1 into B2 plus C1 into C2. Identify the I component, J component, K component and then multiply them accordingly. Now by making use of this idea, we can have a formula for cos theta. Already we have seen that it is A dot B by magnitude of A into magnitude of B. Here it is A dot B is A1A2 plus B1B2 plus C1C2 and magnitude of A is A1 square plus B1 square plus C1 square inside square root and magnitude of B is A2 square plus B2 square plus C2 square inside square root. Again by making use of the same result, we know that when they are perpendicular, theta will be 90, therefore cos 90 is 0, therefore numerator will be 0. Therefore if the vectors are perpendicular, then A1A2 plus B1B2 plus C1C2 is equal to 0. We will be using this result extensively in vectors and also in 3-dimensional idea also. Whenever two vectors are perpendicular, then the sum of the product of their components is equal to 0. Now let us now go for some problem making use of the results which we have seen so far. Find the value of lambda so that the given vectors are perpendicular. We know that the vectors are perpendicular when A dot B is 0. Let us find A dot B. It is very simple. You have to simply multiply. You know that what is A dot B? A1A2 plus B1B2 plus C1C2. Therefore 2 into 1, lambda into minus 2, 1 into 3. Add it now. It is minus 2 lambda plus 5. It is given in the question that A and B are perpendicular. The A dot B is 0. Therefore minus 2 lambda plus 5 is equal to 0. Therefore lambda is equal to 5 by 2. Now whenever you are seeing the word the vectors are perpendicular, use the idea that A dot B is equal to 0. Now let us go to the next question where you have been given the position vectors of the points. Now already we have discussed what do you mean by position vector. When position vector is given, OA is given. Position vector of B is given means OB given. Position vector of C means OC given and position vector of D means OD given. They are the position vector of the points. Prove that AB and CD are parallel. Now when to prove that they are parallel, there are so many ways of proving it. Now let us try to prove it by making use of this cos theta idea. Now what are given to you now? We are given OA, position vector of A, OB, position vector of B, OC, position vector of C and OD, position vector of D. Now we want AB and CD. Already we have discussed how to write AB. It will be the position vector of the terminal point minus position vector of the initial point. About 2i plus 5j plus 0k minus I plus j plus k. Therefore you got it as I plus 4j minus k. Similarly, how to get CD? Position vector of D minus position vector of C. Therefore I minus 6j minus k minus of 3i plus 2j minus 3k. You got this also as minus 2a minus 8j plus 2k. Now we got AB and CD now. Let us find the angle now. Let theta be the angle between the lines AB and CD. Now this will be the same angle between the vectors AB and CD. How to get the angle between two vectors? Dot product by their product of their magnitude. Therefore this is the formula, AB dot CD by magnitude of AB into magnitude of CD. I have displayed here the formula. A dot B, A is AB and B is CD. Now how to do it now? The same thing. We have to multiply that 1 into minus 2 plus 4 into minus 8 plus minus 1 into 2. And in the denominator it is square root of 1 square plus 4 square plus minus 1 the whole square, magnitude of the first vector, into magnitude of the second vector, minus 2 whole square plus minus 8 the whole square plus 2 square. But in the numerator you are getting minus 2 minus 32 minus 2, denominator 1 plus 16 plus 1 inside square root multiplied by 4 plus 64 plus 4 inside the square root. Let us continue. In the numerator you are getting minus 36. In the denominator you are getting root 18 and root 72. How to write root 18? It is 9 into 2, therefore 3 root 2. 72 is nothing but 36 into 2, therefore 6 root 2. Therefore 3 into 6, 18. 18 into root 2 is 2, therefore you got minus 36 by 36, which is minus 1. When cos theta is 1, you know what is it? Theta will be 0. When cot theta is minus 1, theta will be pi. What will happen if the angle is between two vectors is 180 degrees? Then the vectors are unlike parallel vectors. They should be unlike parallel vector. Unlike means they are going in different direction. And remember here AB and CD there is no common point, therefore they should be parallel. And already we have discussed in one of our question, if two vectors are parallel, if you have proved and if they have a common point, then the 3 points will become collinear. But here AB and CD has no common point, therefore the lines are parallel. Now here we have used that parallel idea to prove that the angle between them is minus 1 and there is no common point between them. Question number 3. If A and B are such that magnitude of A is 3, magnitude of B is 2 and A dot B is 6, find magnitude of A plus B and magnitude of A minus B. Now these are some problems which will be making use of the results which we have obtained from dot product. For example, here we have obtained that A dot A is magnitude of A square. Therefore to find magnitude of A plus B, we can't find it directly. Therefore magnitude of A plus B whole square is A plus B dot A plus B. The vector dot the same thing. That is magnitude of that vector whole square. Now expand the bracket on the right hand side. A dot A plus A dot B plus B dot A plus B dot B. Now A dot B and B dot A are one and the same. Already we have discussed commutative property, where it will become twice A dot B plus magnitude of B square. Now let us substitute the values given in the question. Magnitude of A is 3, therefore 3 square. Magnitude of A dot B is 6, therefore 2 into 6. Magnitude of B is 2, therefore it is magnitude of B square 4. Therefore you got the answer as 25. When you take the square root, it will become 5. We cannot have plus or minus 5 because it is a magnitude. Modulus of magnitude of A plus B is 5. In the same way, I think it's not a big issue because we can find directly that magnitude of A minus B the whole square. Once again making use of the idea that A dot A is magnitude of A square. Therefore magnitude of A minus B whole square is A minus B dot A minus B. Expand. A dot A minus A dot B minus B dot A plus B dot B. Once again A dot B and B dot A are equal. Same story, minus 2 times A dot B. Substitute the values now. You got it as 1. Therefore magnitude of A minus B is equal to 1. Here you can very well see that we have applied the property of dot product, that is magnitude of a vector the whole square is the dot product of the same vector with it itself. Okay, well. That is question number 4. Now here we are making use of the definition. If A and B are unit vectors inclined at an angle theta, then prove that sin theta by 2 is equal to half into magnitude of A minus B. We know that we can find only the value of cos theta is equal to we know. Now from that result we are deducting this result. Let us see. Let us now start with magnitude of A minus B whole square. As in the previous problem, it is A minus B dot A minus B. Expand it. you will get magnitude of A square minus twice A dot B plus magnitude of B square. Now on the right hand side, you know the definition of A dot B. What is the definition? Magnitude of A into magnitude of B into cos theta. But the magnitude of A and magnitude of B are 1. Why they are 1? It is given that they are unit vectors. Therefore, you will get that 2 minus 2 cos theta. For right hand side is 2. Let us continue. Magnitude of A minus B whole square. We have just to prove that it is 2 minus 2 cos theta. Let us take 2 outside. It will become 2 into 1 minus cos theta. We already have a result. 1 minus cos 2 theta is 2 sin square theta. But here you are having theta. Therefore, it will be 2 sin square theta by 2. Multiply. It will become 4 sin square theta by 2. Take the square root in both sides. Magnitude of A minus B is 2 sin theta by 2. Therefore, sin theta by 2 is half magnitude of A minus B. This is a fantastic result where we can find the sine of the angle between two vectors when you know vector A and vector B. Now let us go to the next question, which is called a very important inequality in vectors. For any two vectors, vector A and vector B, prove that magnitude of vector A plus B is less than or equal to magnitude of A plus magnitude of B. We start with the same definition of dot product. That is magnitude of A plus B whole square is A plus B dot A plus B. I expand it. It will become 2 times A magnitude of A into magnitude of B into cos theta, because that is the formula for A dot B. But now we have seen one basic condition or the property of sin and cos. Both sin and cos will be less than or equal to 1 for all theta. Cos theta will be always less than or equal to 1. Therefore, 2AB cos theta will be always less than or equal to 2 times magnitude of A into magnitude of B. Whenever you multiply a number by number less than 1, its value will get reduced. Therefore, 2 times magnitude of A into magnitude of B is cos theta is less than or equal to 2 times magnitude of A into magnitude of B. I am using that condition now. You see in the left hand side, I have magnitude of A square plus 2 times magnitude of A into magnitude of B into cos theta plus magnitude of B square, but it will be definitely less than or equal to magnitude of A square plus 2 times magnitude of A into magnitude of B plus magnitude of B the whole square. What will happen to the right hand side? It is of the form A plus B the whole square. Therefore, A square plus 2AB plus B square. Therefore, it is A plus B the whole square. Therefore, left hand side is nothing but magnitude of A plus B the whole square. Right hand side is magnitude of A plus magnitude of B the whole square. Take square roots on both sides. You will get this inequality, famous inequality. Magnitude of A plus B is less than or equal to magnitude of A plus magnitude of B. Now this inequality may be asked in the question to check by giving two vectors A and B. You have to find their magnitude of their sum is less than or equal to sum of their magnitudes. Success is dependent on efforts. All the best. Thank you.